All right, guys, let's go and look at these conic sections from an overall point of view, okay? And of course, by conic sections, we mean equations representing circles, ellipses, parabolas, and hyperbolas, okay? So, conics are called conic sections because they're slices of the cone, as you can see here, and as I have illustrated with the other uh, Desmos files that you'll see. The slices, depending upon how you make the slice, will determine the conic that you produce. Okay, so circles, the easiest of the conics, are when the slice is parallel to the base of the cone or perpendicular to the axes of that cone. Okay, the hyperbola is the cross section produced when the slice is made perpendicular to the base. The slice is made perpendicular to the base or parallel to the axes, and slices there produce hyperbolas. The ellipses are slices which are at an angle relative to the axis of symmetry there, and an angle other than 90 degrees, mind you, okay? And the parabola is the slice which is produced when the slice is at an angle relative to the base, an angle other than 90 degrees relative to the base, if you will, okay? So those are how those are produced, okay? There are two major classifications that I'm citing here for conics. Typically, there's only one, but there's this one which has no B term. So the other expression is going to look exactly like this, but there's going to be a term between the x squared and the y squared, a bxy term, which we call the cross term, which is the more general form. So these are the simpler. These are what we've looked at pretty much up to now. And you're saying, what happened to the B? Well, be thankful it's not there, okay, because it's going to produce a whole lot more work, but we have to deal with it anyway, so we'll see it. Okay, so for classifications of the conics with this form and the C missing, okay, you have this kind of generalization for classification. Circles are easiest because circles are basically where the coefficients of the square terms, the A and the C, are the same, either both positive or both negative, so therefore their product is always positive. A times C is always 0. Ellipses, okay, are going to look very similar to the equations of the circle. Again, these are without the B term, okay, in that the ellipses, the product of the A is also going to be greater than 0, but the A and C terms will be different. The A and C terms will be different, okay? The hyperbola, okay, is going to be with A and C terms whose products is less than 0. That implies that A and C are of different signs. A and C can be the same value, same numeric value, but their signs will be different. So the product of A and C is always going to be less than 0. Okay, and lastly, the parabola is where you either have an A or a C, but not both. So A times C is going to equal 0 because one or the other of those is going to be 0. Okay, now bear in mind this classification is only for these conics where the B term is missing. Only for the conics where the B term is missing. Okay. So what about conics with the B term? They look more like this. This is more the generalized expression that most books will use, and then do the subcategory where B is equal to 0. But any conic will have this form, whether it's a circle, ellipse, hyperbola, or parabola, will have this form. And of course, what we have to learn is the classification of them, which is a little bit more involved than the classifications for the non-B term conics. These, as we'll see, represent conics whose axes are not parallel to the coordinate x or y axis. So we're going to show you some that have been graphed using Desmos. So here is a hyperbola, okay? And as you can see, the axis which runs through the vertex and its focus is not parallel to the axes, and the dead ringer indicator of that is the cross term, the bxy, the 4xy term. So we'll do a process called rotation of axes, which will give us a new equation, but it's the same conic. It's just been rotated into position, or more commonly accepted is that we've rotated the axes, the x and y, to an x prime and xy axes to match the given quadratic, and we'll have more to say about that coming up. Here's another one. Here's a full conic representing all A through F terms, okay? And of course, you want to know what it is. Well, it is a parabola, and you can see if the parabolas with the without the B term would not have two terms squared, and here it is. Here's the alternate version of that parabola that has been determined by rotation of the axis protocol, which we'll talk about in just a minute. So here's the non-B term conic, okay? And of course, it's easy to identify as a parabola just by the equation, because as you can see here, there is only one term being squared, okay? Over here, unless we come up with a method, which we will in the next slide, we wouldn't know that this was necessarily a parabola. Over here, this is easily identified as a hyperbola, because the product of the A and C term is less than 0, and mainly it's identified even without doing that, because you see the difference. Here it's not so obvious, and again, we have to come up with a protocol to discuss that, how that is done, okay? So that classification is going to be measured right here, okay? So we're going to talk about conics which have the cross term, the bxy term, okay, and how we classify them: ellipse, circle, parabola, or hyperbola, by this expression, which looks very much quadratic in nature, the b squared minus 4ac. So here we go, and all we do is we take our conics, and we'll look at some examples in the next slide. So when the conic is when the A, B, and C terms are identified, and they're I guess we can just call this the discriminant, because it's the same form. The b squared minus 4ac is less than 0, and A is equal to C, then we have a circle. If the b squared minus 4ac is less than 0, and the A and C terms are not equal, then it's going to be an ellipse. If the b squared minus 4ac term is greater than 0, we have a hyperbola. And if the b squared minus 4a squared term is equal to 0, we have a parabola. We'll go through some examples of those in the next slide and in the next video. Okay, we're going to stop this one.